Hello everybody, my name is Alejandro Escobar, and today I'm going to teach you how to use a clinometer. I am also going to teach you how to build one. Some things we need to keep in mind before starting to build a clinometer are, first, the SOHCAHTOA. These are trigonometric functions that help us determine triangle lengths and angle measurements. Today, we're especially going to be looking at the TOA. TOA stands for tangent is equal to opposite over adjacent. To understand this, we must also remember the triangle sides. The hypotenuse is always the longest side. The adjacent is the triangle length next to the angle we're looking at, and the opposite is the triangle side length opposite of that angle. So here the angle is x, the hypotenuse is the longest side, the adjacent is the side next to the angle.
To build a clinometer, you will need 5 basic materials. They are a 180-degree protractor, a straw, pieces of tape, an eraser, and a piece of string or yarn. For the first step of the building of the clinometer, you will need 3 items. You will first need the protractor. You will also need the straw and the pieces of tape. So the first step, you will need to attach the straw to the protractor. Make sure that one end of the straw meets the protractor while the other one extends beyond it. When you have that ready, you may tie them. Make sure it is bound tightly. Once you have this safely secured, you may move on to the next step. Once you have that ready, we may move on to the next step. For this one, we will need the piece you just assembled and the piece of string or yarn. With this piece of string or yarn, you will tie it in the center of the protractor, of the side you attach to the string. If your protractor has a hole and the string is big enough to fit through it, tie it through that. If not, tie it through the main bar, but make sure it passes through the center and that it is tightly bound. It should end up looking something like this. For the last step of building your clinometer, you will need the piece you have been assembling and the eraser or small weight. So, you will attach this small weight to the bottom of the string. Again, make sure it is tightly bound. Once you have this, make sure it is able to swing freely. This is your clinometer. Easy to do and easier to use. As we mentioned before, clinometers are used to measure the height of tall objects. We cannot do so with any other method. In my example, will show you how to measure the top of that umbrella. That will be my object.
So, your first step to using your clinometer is to step away from your object. make sure that when you step away, you can actually see the top of your object through your clinometer.
For the first step, you will want to move a few paces away from your object. Just about here is enough. Make sure you can locate the top of your object through your clinometer.
Your second step is to mark your place and measure the distance from your object. So, once you move from your object, make sure you mark your place with a piece of tape and then measure the distance from your object to yourself.
For the second step, you want to mark where you are standing on the floor so you don't forget it. Then you are going to measure the distance from the object to where you are standing. For me, this is a distance of 2 meters and 40 cents.
Your third step is to measure the distance from your eye to your foot. So here in this diagram we can see that this is what we did last step, measuring from the object to your foot. Here we can see that the next step is to measure from your foot to your eye, not the top of your head, your eye. So here we can see that it was first 2.4 meters and this one is 1.62 meters.
For the third step, you're going to measure the distance from your foot to your eye. For me, this is 1 meter and 62 centimeters. Now, for the fourth step, we are actually going to use the clinometer. First, look at the top of your object through the straw, and the object will swing. Then, make sure you record the angle where the object is. So for me, this is 70 degrees.
The fourth step is to use a clinometer and record the measurement given. So here in this example, we can see that when we use the clinometer, it gives us the measurement 70 degrees. And we already have the rest of the information shown in the picture. The thing to keep in mind here is that 70 degrees is not your angle measurement here. To find that, we have to do a very simple procedure. We have to subtract the angle given to us from 90. So 90 minus 70, which is the angle given to us, is equal to 20 degrees, which is our final answer. 20 degrees is this angle over here. So now, what will we do with that information? It's very simple. We will now use SOHCAHTOA, but you're wondering, we need the adjacent side to do SOHCAHTOA. Well, we already have that. 2.4, as you notice, is the same as this side right here. So this is 2.4 meters. And also, we have a very important piece of information here. This is the same as this. So we already know that 1.64 meters is this length. So really, we're only trying to find this. Now you can see the triangle forming. We already have the adjacent side and we already have the angle measurement. So now we'll use SOHCAHTOA, which stands for tan equals opposite over adjacent. So tan 20, which is the angle measurement given to us, is equal to opposite over 2.4, which is the adjacent side. So now, you're doing that in your calculator and you find that tan 20 is equal to 0.36. So 0.36 is equal to x over 2.4. So you leave x alone and multiply 2.4 by 0.36 to get your final answer. X is equal to 0.87. But you're wondering, that umbrella, that tall, can't just be 0.87 meters. Well, you're forgetting something. We found out this piece of the puzzle, but we are missing this. The thing is, we already have that. That is the 1.64 meters that you measured from your eye to the floor. So, 0.87, which is the measurement we found using SOHCAHTOA, and 1.64, which is the measurement given from the floor to your eye, is equal to 2.51 meters, which is your final answer. As you can see, this is very accurate, and it has some room for mistakes, but is really, really close.